How do debugging tools interact with dump files? Have you ever wondered what happens behind the scenes when a program crashes? Understanding how debugging tools interact with dump files can provide you with the answers you need. Let's break it down step by step. When a program crashes or becomes unresponsive, a dump file is created. This file captures a snapshot of the program's state at that moment. It includes details like the process that was running, loaded modules, memory contents, thread states, and call stacks. Debugging tools use this information to analyze what went wrong. The first step is loading the dump file into the debugger. Think of it as opening a frozen picture of the application right at the moment it failed. Unlike live debugging, the program cannot continue from this state, but it allows developers to inspect what was happening. Next, the debugging tools display all the threads that were active at the time of the crash. Each thread has a call stack that shows the sequence of function calls leading to the problem. This is essential for pinpointing where the issue occurred in the code. After examining the threads, developers can inspect variables and memory. If the dump file contains heap information, the debugger reveals the values of variables and the contents of memory as they were at the time of the snapshot. This helps in identifying corrupted or unexpected values that could have caused the crash. Debugging tools also analyze the modules and libraries loaded into the process. This can help identify issues related to specific components or dependencies that may have contributed to the failure. To make sense of the raw data in the dump, debuggers use symbol files. These files map memory addresses to source code lines and variable names. This mapping is crucial for understanding what the program was doing at the time of the crash. Some tools even have extensions for deeper analysis, especially for specific programming environments. Modern debugging tools are versatile. They can handle dump files from various environments, including managed and native code, as well as different architectures and operating systems. This flexibility is vital for developers working in diverse settings. However, there are limitations. Debugging optimized code from dump files can be tricky. Compiler optimizations may change how variables behave and how functions are called, making it harder to interpret the call stacks and variable states. Dump files are particularly useful in practical scenarios. Developers often use them for remote debugging, especially when they cannot access the machine directly. They are also invaluable for post-crash analysis, allowing developers to investigate issues without needing to reproduce them live. Additionally, testers can generate dump files during problematic scenarios to assist developers in identifying bugs. In essence, debugging tools treat dump files as snapshots of program execution. This interaction allows for a detailed inspection of the application's state at the moment of failure. Mastering how to open, navigate, and interpret dump files is a key skill for anyone looking to fix programming bugs effectively.